The holographic principle is basically, and a hologram at any point is the information for the whole object, the whole scene, the whole cup, the whole ball, the whole plate.
Bergson was far more famous than Einstein in the first 2 decades of the 20th century, which is
absolutely
kind of mind-boggling to think of now. Bergson and Einstein had a famous debate in 1922, I believe. The story is, the myth perhaps, is that that debate prevented Einstein from winning the Nobel Prize that year. Is that true?
Yes. Right. There was only one problem, and that was that there was a war going on. And I had been drafted as soon as I got out of the seminary because my draft status was no longer 4D, which was exempt. So I ended up going into the Marine Corps, and I was actually in a long-range reconnaissance group plowing through the jungle, trying with six guys in the middle of nowhere in the jungle, being dropped off in helicopters, et cetera, et cetera.
One of Gibson's big ideas was affordance theory, right? He was that we see
affordance is a big thing. Yes,
we see what is the usefulness of the objects. We see that kind of space. It reminds me quite a bit of Donald Hoffman's theories around. We see the world in terms of what is the most fit for us as organisms, rather than what's actually there. But I know you've done a video on Hoffman.
Right. We're going to blow Hoffman away here, but let me go back just for one.
Fan. Could you tell us about that mystical experience, what that was like?
Shall we say, all of a sudden, just kind of laying on the deck, kind of like, wow, what's going on? And what one felt was that suddenly that there was this other being that you actually were. And this being was infinite. You and this being had been the same being for forever. I guess I'm reminded of a statement by Thomas Merton, the great contemplative monk, a Catholic contemplative monk. And his statement was, in true contemplative state, or actually he meant a mystical state, all concept of sin dissolves, because this being that you are is obviously a divine being and cannot sin. And so when you brought up in the Catholic framework, sin is very much a doctrine and a dogma, and you're worried about mortal sins and venial sins and confessing sins, et cetera, et cetera. And this whole thing just dissolved because it's felt to be ridiculous. It's felt to be, it's no longer applicable. Mm-hmm. And the whole world was just one gigantic sea of love. I mean, it was the ecstasy was so intense, I almost had to have it turned off. And there was another interesting concept that must have come from deep in my being, because I got this. All is just. There was, in other words, justice. Everything. I must have been worried about injustice. In fact, I still am, but but at that time it was like, well, everything is just. So it's very intense, ecstatic experience. Rather, each instant penetrates, permeates the next, like the notes of a melody. Each note penetrates, permeates the next. It's a melodic transformation, an organic continuity. How is these bits, how are they suddenly becoming concrete coffee cups with liquid in them? Stirring, rotating. I mean, come on. When you look at the conception, it's ludicrous. It is not Bergson's conception of a holographic field. Susskind's 2D bit hologram, sorry, but not the same thing. Not even worth looking at. See, you got me mad.
No, that's okay. I mean, you're passionate about it. I get it. How is this theory, Bergson in general, how does this influence your day-to-day life or your moment-to-moment existence, if it does at all?
I, for one, think that science, physics, psychology, cognitive science, given Bergson's framework, absolutely backs the spiritual vision of man, the Zen vision, if nothing more, but probably also the Hindu vision of what our actual capabilities are. I think that there's no conflict between science and this whole notion that's permeating people's minds right now, that neuroscience says we're just human robot forms with no spiritual component whatsoever, is utterly destroyed by Bergson, and gives us a very solid grounding in science and our own mystical experience that supports it. So I guess bottom line from that perspective, Bergson is a great comfort. And if people want to shed the transhumanist vision of the idea we're going to all get a nice bunch of chips because that's all we really are anyhow, and just become enhanced robots. And also there's no God, there's no karmic laws, and et cetera, et cetera. That, get into Bergson and you'll see quickly how just shallow and superficial and understanding they actually are. I don't include people like Sam Harris or Daniel Dennett, et cetera. These people are, in my mind, are extremely badly misled because they extremely do not understand the problem of consciousness and time. So that's one thing. After that, it's been a giant pain because I never thought that after 50 years that this particular conception would be so buried yet. It's buried in cognitive science that no one wants to look at it. It's buried in memory theory, it's buried in perception theory. It's buried by the Gibsonians, for Christ's sake. They won't even look at it. It's buried by the Bergsonians, for that matter. Even Bergsonian philosophers can't do it. Well, who can't deal with it? I can just feel it. They don't want to deal with it. Oh, it's too much. Can't deal with that. So it's become a frustrating pain, and I feel like my life's mission has been a bust. So I feel right now. I'm just tell you the truth. It was a good try. Maybe someone later will come along and take it up, because right now, to me, it's completely being ignored.
Steve Robbins has a PhD in Educational Psych and Psychology from the University of Minnesota with a focus on cognitive science. His thesis covered turn of the 20th century French philosopher Henri Bergson and his alternative model of mind. In the decades since, he's published academic journal articles and 3 books on Bergson/consciousness. Before his doctoral work, he served as a Marine infantry officer in Vietnam. After 33 years in the software industry, he's now retired on a mini farm in Wisconsin and runs a YouTube channel with over 80 videos dedicated to Bergson and his holographic theory. Steve, thanks for coming on.
Oh, thank you. It's a pleasure.
Yeah, it's so great to see you and get to chat with you. I've discovered your channel many weeks ago and have been, digesting each video. They're dense, but I highly recommend people check them out. After this conversation, I'll link all of your link to your YouTube channel and your website in the description of my video.
Right. It's a tiny point in internet space somewhere. The channel.
Yes.
Which takes a voyage to discover, apparently.
Yeah, absolutely. A lot of competition. You have to.
Yep.
It's a tough market. I know. I'm a similar size channel, so I get it. So, Steve, It'd be great if we kick us off. I know you have some prepared slides. If you want, you can pull those up. I'd love to. I know you have some at the beginning that goes through your background a little bit in even more detail, because I love to learn. I know our audience would love some context on you, to get your story and to figure out what intrigued you so much about Bergson. I consider you one of the world's experts on Bergson. So if you wouldn't mind, pulling that up, we can get into, and the visuals of your story are great too. I think seeing the trajectory of your career.
We're going to have to go visual, as you noted, because there's a lot here to comprehend that 2 talking heads make it very slow to get across. So some pictures work well, but
yes. For the viewers, if you like visuals, Steve provides a lot of visuals on his YouTube channel and extensive quotes that help elucidate the concept you're trying to get across.
We were thinking about beginning how it began with where I come from, I guess, is the
let's get your background. Where'd you grow up? Where'd you grow up? I mean,
So I'm basically a Minnesota native. I'm sitting in Wisconsin right now, a little bit north of Milwaukee. I spent a good chunk of my life, like 7 years, as a Franciscan seminarian down in Chicago and ultimately in Illinois. In fact, there's a good picture of there's my seminary in Illinois, in Westmont, Illinois, and that's not me, but that's some Franciscans. So that, just to give a context of what I'm talking about, because I spent the last year, 1966, in the novitiate. We were actually dressed up in the habit and walking around with your cord and your rosary and et cetera, et cetera. But I decided to.
Can you tell us what do you mind giving us some context as to why you were temporarily joined the Franciscan order?
Well, I would say this. My folks were very very Catholic, very dedicated, very devout, and I had some sort of shall we say, affinity toward this. I remember reading The Life of St. Francis, Perfect Joy of St. Francis, when I was 7 years old. And that already started me off right there. I was going to be a Franciscan. And
wow, at 7.
Yep. Yeah, that division experience was quite the deal. I was, you got up at midnight and chanted the divine office for an hour, and then meditated, and then went back to bed and got back up at 6 and did more chanting of the divine office, tertium lauds or whatever in Latin, and then go through the whole day. There was no talking, etc. But I left in the spring of 1966 because I decided ultimately, after 7 years and lots of Latin and Greek and German and the interesting education that was available at the time in that environment, that it wasn't quite the fit for me, and so I ended up going to the University of Minnesota. I had to finish off my undergrad, cram 2 years into 1 year at Minnesota, and I was in psychology and political science. Political science was my thing, but I like psychology and the mind, and but that little place there was the absolute haunt of Skinnerian behaviorism and his rats. And the very last course I had in the spring of '66 was by a professor from Michigan who was teaching Piaget and cognitive development and the whole theory that actually there's something in the brain that Skinner denied. For Skinner, you weren't even supposed to, the brain was off limits. You didn't look in the brain. But here you had Piaget talking about cognitive development, and that somehow turned me back on to psychology. And there was only one problem, and that was that there was a war going on. And I had been drafted as soon as I got out of the seminary because my draft status was no longer 4D, which was exempt. And so I ended up going into the Marine Corps for reasons I won't go into. And I was actually in a long-range reconnaissance group plowing through the jungle, trying with six guys in the middle of nowhere in the jungle, being dropped off in helicopters, et cetera, et cetera. So I spent 68, 69 doing that. And
wow. And Steve, thank
these
you
are
for
always
your service.
interesting experiences. And I came back to the States, and I guess that's a piece it's hard to picture here, but I was very, I call it involuted, because when you go through an experience like that, you're wondering why you survived. And what's the meaning of life? And what the heck is this all about? And so you sort of go into an intense inward state. And in that state, toward the end, I was in North Carolina, on the seacoast, the inland waterway. I was living with 3 other ex-officers, or they were still officers in the Marines, but on a yacht, top of a yacht base and yacht club, kind of. But I had what one would call a mystical experience, and which again had an impact on me, because I'm used from the seminary, from a course I took in epistemology, which I didn't have a clue what was going on about. There's something problematic with the relationship of subject and object. And we'll come back to that in this discussion. But
yeah, Steve,
that mystical experience sort of enhanced that whole perception that, this is quite interesting. And you see, Piaget, back to him, he was sort of describing how the child starts out in actually kind of a mystical state where he's one with the world, and only gradually does he learn that he's a self among other selves, an object among other objects, a force among other forces, and that he has an identity himself with respect to this other matrix of beings, forces, and objects. And so, in essence, it's the description of how one goes from a, shall we say, infant mystic to excuse me, needing a Zen koan to break through back to this original state where you are one with the universe, shall we say. So that all struck me. In fact, that kind of became my thought, and well, this is what I really should maybe look at if I go back to the University of Minnesota, which my next arrow says, I'm back to Minnesota in 1971. They let me out of the Marine Corps early.
Do you mind, Steve?
Yep.
Sorry, I hate to interrupt you because you're in a great flow here. But if you care to share, and I know it might be a very personal experience, so please, if you don't want to, if you don't care to, but could you tell us about that mystical experience, what that was like?
It's a little hard to describe, but it was. I kind of found myself, shall we say, all of a sudden, just kind of laying on the deck, kind of like, wow, what's going on? And this, what one felt was that suddenly that there was this other being that you actually were, and this being was infinite. And you and this being had been the same being for forever. And I guess I'm reminded of a statement by Thomas Merton, the great contemplative monk, that Catholic contemplative monk, in his statement was in a true contemplative state, or actually he meant a mystical state. All concept of sin dissolves, because this being that you are is obviously a divine being and cannot sin. And so when you're brought up in the Catholic framework, sin is very much a doctrine and a dogma, and you're worried about mortal sins and venial sins and confessing sins, et cetera, et cetera. And this whole thing just dissolves because it's felt to be ridiculous. It's felt to be, it's no longer applicable. And the whole world was just one gigantic sea of love. You know, I mean, it was the ecstasy was so intense, I almost had to have it turned off. And there was another interesting concept that must have come from deep in my being, because I got this: all is just. There was, in other words, justice. Everything. I must have been worried about injustice. You know, in fact, I still am, but but at that time it was like, oh, everything is just, and so it was very intense, ecstatic experience, and with the awareness that there really was no death. You had been this being. This whole notion of sin fell away because, well, there's lots of implications in that. So, that's pretty much the content thereof. Wow. Okay, and it wasn't long thereafter. I mean, well, it's kind of funny because I lived with one of the lieutenants I lived with. His nickname was Duke. He had been over in Vietnam for 18 months. The normal 12-month tour, and then his troops, his platoon, turned him on to marijuana because they thought he was a cool guy, and he re-extended for 6 months just to do the marijuana.
Wow!
And then he'd be walking around. He was in LSD, and he could be on an LSD trip, and you never knew it. You know. Yeah.
Wow! Interesting guy.
And because I had gotten out of the Marine Corps. About a week after that mystical experience, he took me on an LSD trip, which was quite interesting, which also helped in the ultimate breakthrough one needs to understand Bergson, because Bergson, as I'm going to point out, is very Zen, very mystical. And people that are not Zen and not mystical and don't have this intuition, I think, have a very hard time understanding Bergson. Sure. So like I said, the arrow, I ended up back at the University of Minnesota fall of 1970, starting 71. I'm back in graduate school in educational psychology. It was really called the Cognitive Foundations of Education. It's really a cognitive psychology thing. Mm-hmm. Philosophy was, and ultimately computer science is going to come along.
Right. Yeah.
Because that was the '72 was the big year that computer science swept into academics, into cognitive psychology. And the interesting thing you and I talked about before is that how I hit Bergson. And the reason was I found a course right away with a Dr. Bart, who was into was into Piaget, and it was a discussion about, or devoted to, Piaget's group theory, use of mathematical groups, which I think he got from Ernst Cassirer, and initially, the great French phenomenologist or German phenomenologist, philosopher. And my thing was I was going to write something about the epistemology of Jean Piaget. This came from my one course in the seminary on epistemology and my association or discovery of Piaget at the end. And I had no idea what I was going to do, but I thought it was cool. And Dr. Bart says, well, why don't you write a comparison of Bergson to Piaget? I thought, oh, okay. I'm thinking, who's Bergson? I have no clue. I don't have a clue who Bergson, but I could do that. Yeah, sure, I could do that. Yeah. I'm going to do that. So, I discovered you go to the library and you find books on Bergson, because you're never going to, you wouldn't want to read Bergson right off the bat, but you find somebody's going to distill it for you, hope. In my Wilden car, I found a book on Bergson, and this is what I ran across right off the bat, and about 3 or 4 pages in the car. This statement by Bergson: questions related to subject and object, to the distinction and their union, must be put in terms of time rather than of space. And I thought, whoa, that's cool. Subject and object. I have no clue what that thing meant. I mean, what is that? That's why I have the Zen picture there. It's a koan. Sure. Yeah. It's like what is the sound of one head clapping, or who is it that sees? Okay, right. It's the koan that you have to contemplate. Well, I didn't know what that meant, but that was enough to tell me that something cool is going on. And
do you mind, Steve, if we quickly just give folks a context as to when Bergson lived? What is I mean, I know, but you're the expert, so.
Well, of course, I forgot when he was born right off the bat.
Yeah, I mean, mid 1800s, late 1800s.
Yeah, he's writing his thesis in 1889. Okay, his thesis was Time and Free Will. That was the title of it. 1889. So he's probably about 20. We can probably go back to about 1879 or something like that, when he was roughly born. So so much for my Bergson expertise right off the bat, down the drain. But he is obviously French. He was quite brilliant. I mean, he was extremely diplomatic. His classmates said he could destroy your theory in a matter of a few sentences, but he did it very diplomatically and nicely. He won at 18 a very prestigious French prize in mathematics, and he greatly then disappointed his mathematics professor, because he decided he was going to go into philosophy. And that professor said, well, you could have been a mathematician, now you're just going to be a philosopher. Right. And I'm pointing this out because there's a great mythology about Bergson ultimately, because he ultimately gets in a big argument with Einstein over relativity. And I think he beat the heck out of Einstein in terms of proper interpretation of relativity. That's another story we may not even get into. But the myth is that he did really understand mathematics. And even Einstein ultimately admitted, well, yes, Bergson totally understands the theory of relativity. But believe me, he when you look at Bergson's book on relativity, he just dismantles, dissects, and reconstructs the whole theory mathematically.
Sure. Is it true that,
and obviously effortlessly,
their famous debate, Bergson and Einstein had a famous debate in 1922, I believe. And is it true? I mean, the story is, the myth perhaps is that that debate prevented Einstein from winning the Nobel Prize that year. Is that true?
Yes. Right.
Yeah.
Right. And there's a whole book on it now by Jimena Canales
Yeah.
called The Philosopher and the Physicist, which is the great title,
Yeah.
going through the debate. And unfortunately, she completely misses the actual essence of the debate, which is a problem. But
And
maybe
Bergson, yeah.
we'll get
And
back to that.
Bergson, one of my pieces of research, this person claimed that Bergson was far more famous than Einstein in the first 2 decades of the
Yes,
20th century, which is
absolutely.
kind of mind-boggling
Yes,
to think of now.
right. Because what happened is he published this Time and Free Will, which was taking the problem of free will in the context of the nature of time, which still is ignored today completely. You can read Dennett, and A, you don't see Bergson mentioned, B, you don't see time mentioned, Dennett on free will, Dan Dennett. And in fact, almost all of the current discussions on free will. He follows it up. He spends 5 years studying memory difficulties, aphasias, amnesias, lesions to the brain, and comes out with this book. I got a picture there, Matter and Memory, of 1896, because his whole problem was, does the brain actually store experience? Does it store that coffee cup out there in front of my guy there with the stirring spoon, that experience of the coffee stirring? Is that stored in the brain? And his point was, the whole theory of consciousness rests on this question: is experience stored in the brain? And again, you won't find that question ever mentioned anywhere, not by Chalmers, not by Strauss, and not by any of the people that are the supposed great theorists of consciousness nowadays. Not just simply not understood. The bottom line, his analysis of the subject of all the phenomena, memory research at the time, was that it couldn't be stored in the brain. It was not stored in the brain. You did not have to have that hypothesis, which is now a dogma, that memory is stored in the brain. In fact, all that could be happening is that the brain, when it's damaged, simply can't, let's say, form the proper neural patterns or modulating wave patterns, I'll call it, that allow the memory to be reinstantiated, the original experience, but not from within the brain itself. So that's another whole question we ultimately probably actually quite won't get into, but we'll see part of it.
Yeah.
And then in 1907, he followed up with a book called Creative Evolution, which was a tour de force on the problem of evolution, the problem of Darwinian evolution. He was not a fan of Darwinian evolution, and really the whole nature of the evolution of the universe. I mean, Teilhard de Chardin, who actually I was reading at the time of my mystical experience, I should say, was the great Catholic Jesuit, a kind of a mystic theorist, was inspired by Bergson's work, Creative Evolution. And he was launched by that point into quite a bit of fame and famedom, to the point where the ladies of Paris wanted to attend his
right.
lectures, and there was discussions of whether he should hold the lectures in the Paris Opera Hall because the attendance was so great.
Yeah, he was a local celebrity in Paris, right?
This, of course, also generated its own self-resistance, because now you had other academics that were like Bertrand Russell that were extremely upset, or shall we say, we won't use the word jealous, but they didn't like this. Too much popularity. Sure. And Bergson took a lot of shots. But the bottom line, to not make this too long, is that his popularity, well, again, he really emerged back in 1922, like you noted, because he had, being the great theorist of time that he was, his ears pricked up when he discovered that Paul Langevin had announced what's called the twin paradox. If you remember, where the twin leaves the Earth in the rocket, comes back, and he's ageless in his brother. And Bergson thought that was a complete misuse of relativity. It destroyed the logical consistency of relativity. Hence, he began his arguments. It got ultimately discussed with Einstein, wrote the book Duration and Simultaneity. And that sort of began this period. He was actually working with Einstein in I think the League of Nations at the time too. So he was somewhat prominent in politics at the time, but that was the beginning of his gradual descent into obscurity and waiting in the wings, as I like to know, was behaviorism, Skinnerian behaviorism, the analytical philosophy, which is very antithetical to Bergson's continental philosophy. And he ended up dying of pneumonia after standing in the line for a long time in Paris, 1941, occupied by the Germans, by the Nazis. He got pneumonia. He was going to declare himself a Jew publicly, as the Nazis were demanding. So he died of pneumonia, and that was the end of Monsieur Bergson. And as I said, he sort of then went into obscurity. And so that's him. So meanwhile, someone like me comes along and discovers this quote. We're sitting right now.
Just quote, back to the quote. Yeah, thank you for the context. That's helpful.
Okay. So that began my reading of that book, Matter and Memory. I mean, I must have read it a dozen times, in backwards, forwards, from the middle outwards, every direction, because when you hit Matter and Memory, you really don't know what's going on. And the book was considered, especially its first chapter, obscure even by his adherents, by Bergson's adherents, and we'll see why. So I'm in Minnesota, and what's about to happen in Minnesota is the computer model of mind is going to sweep in 1972. The whole notion of the brain as a computer. My advisor in the education psychology side was very enamored of a book by Newell and Simon called General Problem Solving, Human Problem Solving, which went through their book with their model of a computer model, the general problem solver, which tried to simulate solving problems the way humans do, like cryptarithmetic problems, like Donald plus Gerald equal Robert, which we have to assign numbers to each letter, like to Donald and to Gerald get Robert, or chess was another one of the things in their books. So that's swept in. And the other side of the story I was related to was on the pure psychology side was what eventually became my thesis advisor, Dr. Bob Shaw. And I think that's where we're having subject and object here. I forgot to put that.
Sorry.
Oh, I have to remember my source of my thing. So let's before I go to Shaw, let's go to this point in Bergson. Here's another of the koans. This is in chapter 1 of that book. He says, but isn't that obvious? See, Bergson is talking about how do we see the coffee cup out there, and in space, extended out there on the table. How do we see that coffee cup? Is there a photograph of the coffee cup in the brain? And he says, well, obviously, is it obvious the photograph? He said, I got to keep my things in order here, but neuroscience at the time was developed enough to know that there was no coffee image in the brain. You weren't going to find an image of the coffee cup in the brain, which is why I have the little red circle there with a line through it. So he says, excuse me, but isn't that obvious? The photograph, if photograph there be is already taken, already developed in the very heart of things and at all points in space. No metaphysics, no physics can escape this conclusion. Build up the universe with atoms, each is the subject to the action, variable in quantity and quality according to the distance, exerted on it by all material atoms. Bring in Faraday's centers of force, the lines of force emitted in every direction from every center bring to bear upon each the influence of the whole material world. Call up the Leibnizian monads, each is the mirror of the universe. So that is key to his answer to how we see the coffee cup. But you can see it's yet another koan. It's koan number 2, along with subject and object in terms of time. So I have no idea what that meant when I read it. He went on, he was actually before this, he was talking about the nature of the universe. Take any object, for example, like the coffee cup there. Any object is obliged to transmit the whole of what it receives, to oppose every action with an equal and contrary reaction. To be, in short, really the road by which pass in every direction the modifications, or what can be termed real actions, you visualize waves, propagated throughout the immensity of the entire universe. Okay? So he says, so only if we consider any other place in the universe, we can regard the action of all matter as passing through it without resistance and without loss, and there the photograph of the whole is translucent. Here is wanting behind the plate the black screen on which the image could be shown. Our zones of indetermination. There he's talking about organisms, centers of free action that can act upon the world, play in some sort the part of that screen. They add nothing to what is there. They affect merely this. The real action, those waves passing through the coffee cup that the coffee cup is reflecting and sending back to all the other points in the universe, they affect merely this. The real action passes through those waves, and the virtual action remains. Okay, so if anyone here listening to this knows what this means already, let me know. But unless you picked up what I've said, but you can see that this is pretty much koan-like. Very difficult to understand what's going on. And he's talking about the problem perceiving that coffee cup, seeing that coffee cup out there on the kitchen table, which is really the hard problem. And we'll go back to that. That's the hard problem. Mm-hmm. Always see the coffee cup out there with its qualia. Okay. So this is where I was going. My other advisor, who eventually my thesis advisor, was Bob Shaw, on the bottom there. Robert E. Shaw. Now, he was a student of Gibson at Cornell for a couple of years. Now, Gibson, top the picture, J.J. Gibson. There we have his dates, 1904, 1979. To me, he was the greatest theorist of perception that walked the planet. Wow. Maybe next to Bergson, but actually pure theorist of perception on Philosopher. But he was very philosophical too. He founded the subject of, we'll call the subject of ecological psychology, which is, there's now a journal today, the Journal of Ecological Psychology. It's a whole field or subfield in the study of perception. And Shaw, my advisor there, was the founder of that journal, the Journal of Ecological Psychology. He obviously knew Gibson. He studied with Gibson at Cornell for a couple of years while he was studying abstract automata theory at Cornell. Abstract automata theory is, shall we say, another level of abstraction above computer science. It's the abstract logical description of finite state machines. And Bob was a brilliant guy, as we'll see.
Sure, yeah.
I think it'll become fairly evident.
On Gibson, if I may hit just a quick tangent, one of Gibson's big ideas was affordance theory, right? He was that we see
affordance is a big thing. Yes,
we see what is the usefulness of the objects. We see that kind of space. It reminds me quite a bit of. Seems analogous to, although I'm sure there's differences between Donald Hoffman's theories around sort of our fitness. We see the world in terms of what is the most fit for us as organisms, rather than what's actually there. But I know you've done a video on Hoffman.
Right. We're going to blow Hoffman away here, but let me go back just for one thing here.
Sure.
But we won't do it here.
Yeah. No, I just wanted a little quick tangent.
Just say, let's go back to this. Look at the very bottom line, okay? Virtual action. That's affordances, as we'll see.
Oh.
So just a little preview. Okay.
I was going to ask you, I know virtual action, there's a few terms that you use that when we get to them, I am going to stop and say, let's really define this and get this down. So virtual action is essentially affordances.
Right.
Okay.
Well, yes, but it's worse than that. So we're going to see. We have to take it in a holographic context. So
sure. Back
to where I was. Okay, so let's see what my next slide is. Okay, so we're going to get there. So in 1972, like I said, this computer model swept in. I attended a seminar with Shaw, and he went through Feigenbaum's book on computers and thought. And Shaw simply destroyed the whole notion that the computer model of mind had anything to do with reality back then, already in 1972. Around that time, also, Karl Pribram, I don't have a picture of here, published his book called Languages in the Brain, where he argued that the brain was a hologram. And that accounted for how the brain stored memory. He was trying to buttress the findings of Carl Lashley, where Lashley had tried to destroy memories in the brain and couldn't do it, and decided that, which basically, if you took what Lashley was doing, he was also destroying anything that would be considered neural nets today. But that's another question. And but Lashley decided memories must be somehow very distributed, and holography, as we'll see, is the essence of distribution. And Carl was trying to argue that, and he had a very minor theory of perception at the time in Languages of the Brain, how we see that coffee cup out there. That maybe the holography has something to do with that, but it wasn't a real coherent theory. But Shaw had invited Pribram to come to a conference and to talk at a conference at the University of Minnesota, and pretty obviously that the two had discussions, and shall we say the next day that Pribram was there, Shaw was giving his seminar, and he started talking about holography, and so we'll quickly talk about holography, the construction of a hologram. And so in the construction of a hologram, we've got the hologram plate there, and we've got a form of laser light to the left. That would be a laser, a coherent frequency laser. And so the waves from that laser are hitting the hologram plate. And then, I don't have a picture there, but normally some of those waves are bounced off of half mirror to the object or the scene, the pyramid of the ball there. So you would have some waves bouncing off the ball in the pyramid and bouncing back toward the plate. So that's called the object wave, as I've got labeled there. So the hologram is the interference pattern of these two waves, the reference wave and the object wave. And I was going to put a nice picture of an interference pattern there, and I forgot. But it's just a jumble of lines that look nothing like the pyramid and the ball. But that's our hologram. It's a jumble of lines, the interference recording of the interference pattern of those two waves. And now the reconstruction process is interesting. If I beam a wave of light, a coherent wave of the same frequency as the original wave, of the original reference wave, that's now called the reconstructive wave, the reconstructing wave set, I'll just label it frequency 1. We're beaming that back through the hologram plate. And what is specified is the source of this original object wave front, namely the pyramid and the ball. So notice that's called the virtual image. Virtual action, but now virtual image. Okay, that's the virtual image. And you can move your head around, notice the viewer up there, he can sort of, he's seeing the behind the plate, as it were, out in space, the image of the pyramid and ball. And he can move his head around and sort of see the side of the pyramid and the side of the balls. It's a 3D image, so to speak. So that's reconstruction. That's the reconstructive process. Let me see what my next slide is. Now, one can store multiple wavefronts on a hologram. Okay, so on the left there, I've got the frequency 1 case, a reference wave of frequency 1 being used to store the pyramid and the ball interference pattern. I can change my reference wave frequency and therefore my reconstructive wave frequency to frequency 2, store an image of a cup, and that wavefront also interference pattern is also on that plate. And so if I modulate the reconstructive wave from frequency 1, where I'm specifying the pyramid ball, to frequency 2, I'm specifying now the cup. I can modulate it back to frequency 1 and see the ball again. So I can modulate the reconstructive wave. Okay. So far, so good. I'm in the footsteps of Shaw here. Mm-hmm. So then what Shaw says is, well, rather than looking at the brain as being the hologram, what if we look at the universe as being the hologram? The universe is the holographic field. Mm-hmm. In other words, as he said, the hologram is not in the head is in the hologram. And the brain is acting or is creating the reconstructive wave, passing through the holographic field and specifying a source within the field, the coffee cup, stirring spoon, the table. Okay. So he's flipping Pribram's thesis around completely. And that's when I realized what Bergson's talking about. But isn't that obvious that the photograph, I got to move your picture.
That's okay. Yeah.
But isn't that obvious that the photograph, if the photograph there be, is already taken, already developed in the very heart of things and at all points in space? What Bergson was describing in that obscure chapter 1 was that the universal field, the field of matter, is a holographic field. It's each point, and that's a little slide I forgot to do. Because each point in that field is the reflection of, has the information for all other points in the field. If I go back to this slide here, for example, if you look at the cup, okay, visualize it as a set of points, okay, where each point is giving rise to a spherical wave. Okay, this is in the. Let me go back one more.
This sounds. I mean, it's related to. Would you say there's clearly a relation to quantum mechanics here, where, waves and particles, etc. I'm sure.
I wouldn't go into the quantum mechanics black hole on this yet. Okay.
Okay.
But here. We'll go, instead of the cup, go back to the ball. This is we're constructing a hologram. Okay, each point on the ball can be considered as giving rise to a little spherical wave that goes out toward that plate. All right, and covers the entire plate. Okay, so the information for any one point in that ball covers the entire plate. But conversely, then when you realize a whole set of points of that ball covering that plate, then that at any point in the plate is the information for the entire ball. Okay, so one point, the spherical wave from one point covers the entire plate. But now when you see there's a whole set of spherical waves covering the entire plate, you realize that in any point in the plate, is the information for the whole ball and the pyramid. So the holographic principle is basically that. In a hologram, at any point is the information for the whole object, the whole scene, the whole cup, the whole ball, the whole plate. So that's back to this. We were. The photograph is already developed the very heart of things in all points in space. At every point in space is the information for the whole. So we don't need a photograph. And then you've got this next quote: our zones of indetermination in the organisms play in some sort the part of that screen. They add nothing to what is there. They affect merely this. The real action passes through. The virtual action remains. So remember in the previous picture, you're seeing the virtual image, the virtual image of the cup, or the so that's the virtual action remaining. So
what would be the real action?
Well, the real actions, going back to the other quote, is all those remember Bergson talked about this massive set of real actions, where that, if you look at my little picture there of all the lines and waves in my little symbol of the universe as a holographic field, we're only picking out that set of real actions, those waves that are interesting to us, that actually relate to the body's capability for action. Okay, so hence why it's virtual action. You're seeing how you can act. You're seeing the possibility of action. I can act on that cup. I can act on that table. We'll see this more again. Or it's in other words, the cup presents affordances.
Sure. So the virtual action, and the real action would be everything else that we don't perceive.
Yes.
Okay.
We're embedded in the field of real actions. What we're seeing is the virtual action, that subset of the real actions that the brain and the body are picking out as interesting to it, that relate to its capability of action. So when you upgrade Bergson remember the holographic model, the notion of a hologram wasn't discovered until 1947 by Gabor. Matter and Memory is 1896. That's why no one understood it. It didn't have this physical model there to get it. Even when I tell people about it now, they still don't get it, but that's another question. But when you upgrade Bergson then into the holographic language, you'd be taking these quotes, you'd be saying, well, the universe is a holographic field, and the brain is a reconstructive wave specific to a virtual image within that field, the coffee cup and stirring spoon. And as we'll see, it's a modulated reconstructive wave because coffee stirring itself is very dynamic. All these events are dynamic. So the brain is constantly being modulated, dynamically transforming, as we'll see.
Can you define what modulation is?
Well, that was back to the picture where we simply were changing frequency from frequency 1 to frequency 2 to frequency 3. We're modulating the frequency to a different, modulating a wave to a different frequency. Okay?
But as I understand...
Like frequency modulation.
Sure, so forgive my ignorance, but when I think of modulation, and let's make sure we're trying to be on the same page, I understand it as a signal that's sent to help the transmission of information, or not help the... See, this is where the limits of my understanding kind of go. But
right, but
does that make any sense? It's like sending another signal through a signal.
Right, but you're simply
make sense of it.
Even in that framework, I think you're trying to get to. You're basically modulating the wave into a certain pattern or form. Okay, so that it carries so it's, you modulate that wave so it carries my voice pattern, my voice frequency. Okay, so that it's reflective of my voice up and down. Okay, it's a more complex modulation. In fact, this is going to be, and ultimately, this is going to be a very complex form of modulation that we're talking about here. But the simplest form is just simply changing from frequency 1 to frequency 2 to frequency 3 and back to frequency 2. Simply modulating that wave to the different frequencies. That's the simplest form of it. So I got to see where I'm going here. So as I was saying, so the brain is in this framework is a modulated reconstructive wave. Put the brain here, and it's specific to or specifying the cup. Now that cup is right where it says it is. Now here's another. I have another picture of modulation here, modulated reconstructive wave. Let me move from frequency 2. See the cup. Frequency 3, the wine glass. Frequency 1. Again, changing that.
What would be the purpose of changing the frequencies?
Well, if you remember, each of those objects was stored with a specific reference wave of the same frequency. That cube was stored with a reference wave of frequency 1. So the interference pattern is kind of related to frequency 1. It's a function of frequency 1. The cup was frequency 2, and the interference pattern, the way the waves all mesh, is a function of that frequency 2 and the object wave from.
Sure. So if you could, in our moment-to-moment existence, how many frequency waves are we talking about in terms of what we can perceive? I mean, are we talking like an astronomically large number?
Well, at that, what we're going to see here is that this talking in terms of a simple frequency like this is a way to get the mind going into how this process works, how the holographic specification process works. But when you're talking the brain and the event that's driving the brain, namely this coffee stirring, okay, you're going to have an extremely complex pattern, modulation pattern, we'll call it, that where the notion that it's a simple frequency kind of fades, right, into and you're looking at something far more complex.
Sure.
So hang on, you'll see that in a second when we get there with a little more in Gibson. What has to be brought in? So as I'm saying, it's specific to or specifying this wave. The brain is now specifying the cup right where it says it is in the external field. It's not right where it says it is. As common sense says to us when I'm looking at my coffee cup out here on the desk. That's where it is. It's not constructing an image. No, it's not an image inside the brain or in some mental space or perceptual space somewhere. Like you'll get theorists talking about, like Yosha Bach will say, well, it's in a perceptual space. Well, what's a perceptual space? So this is what's called direct perception. That is, indirect perception would be the picture up there where the image of the cup is in the cloud, shall we say, in the mental space or in the brain somehow. And somehow that corresponds to the world out there, in some magical way. But direct perception says, no, you're directly seeing the cup right where it says it is, external in the field. We're not constructing an image in the brain. Mm-hmm. Now I'm saying, when driving, here we're getting to your question, what's really driving the modulation? It's what I term the invariant structure of the event. And we'll talk about that, where this event is extremely complex. It's got velocity flow fields in the swirling of the liquid, adiabatic ratios, which are, when you're stirring it, energy of oscillation, the frequency of oscillation, it's a ratio to that. Inertial tensors, which have the momenta of the spoon, the various force momenta of the spoon. Acoustical invariance, like the clinking of the spoon, which is always coordinate with the motion of the spoon, etc. So we're going to go into that because that's going to take us into Gibson. But every such event has such a structure, and that's driving the brain. We'll get into that. And it's all being specified at a scale of time, because that brain has chemical velocities, and this is a neural dynamics there, underlying which are chemical velocities, which can be expressed in the Arrhenius equation, and can be modulated too. It can be changed. You can drop a catalyst, which lets the reactions occur more quickly with not as much energy, raise the whole chemical velocities. So the brain we're seeing the world specified at a normal scale. Normally the buzzing fly, 200 wing beats per second. But if you raise the energy state of the brain, increase the chemical velocities, it could be specified as a heron-like fly, barely flapping its wings, or even raising it still higher, just a cloud of electrons. So we have to break what I like to call the scale fallacy, that the world just exists at this scale. It does not. There's multiple scales, and the brain is specifying a specific scale. So this wave is supporting, it's a reconstructive wave, and specific to a scale of time.
So would a fair way to, I'm just trying to perhaps simplify it for the audience. There's waves, there's a holographic field made up of waves out in the world. There's waves in my brain, and the waves in my brain are connecting with the waves out in the world.
One could look at it that way. Yep.
Okay.
That's a start.
Simplifying. I mean, that's a really...
But you know, because there's these levels of description. You can see it as waves, but now notice I just described, okay, the coffee cup's a set of waves, but also at another level, and so she has scale, it's all these invariance laws. Okay, the swirling flow field, the adiabatic ratio of energy of oscillation of frequency as I stir. So what I had pictured there in that,
do you mind just defining invariance for the audience?
We're going to see it in a second.
Oh, great. Awesome. Thank you.
We're going there because this is why I have the picture of Gibson there, and the fact that Shaw was a student of Gibson, because Gibson was the pioneer in describing the importance of invariance laws in the world, and he saw this information as being part and parcel of the direct specification of the coffee cup out there. So here's an example. You have what's called a texture gradient. And the texture gradient is a whole pile of texture units. My little circles are the texture units, and they recede in the distance. The horizontal, there's a little mathematical law. The horizontal distance between each little unit is inversely proportional to the distance from the observer. S is proportional to 1 over d. And then the vertical separation going back, notice they get completely compressed. That separation is specified by the law 1 over d squared, or the separation is proportional to 1 over the distance squared from the observer. Okay, so that's an interesting little thing.
Does that have
Does
that have to do with our field of vision, or is this just how? Sorry, if you could go back a step.
Yep.
Yeah, because I find this very interesting that there's different laws for horizontal versus vertical distance. Why is that?
The point I forgot to mention: these fields are ubiquitous. Okay, these are gravel. This is your gravel driveway, your field of grass, your beach sands, etc. If I turn it upside down, it becomes the cloud ceiling, stretching off in the distance to the back. If I turn it on angles like this, it becomes the walls receding. Okay, it's what's being said here is this is an inherent intrinsic mathematical law within these fields, these texture gradients. Okay, and it becomes useful because if I move the cup across this gradient, there's an invariance law relative to those texture rows that specify that the cup stays the constant size. Notice there it's including roughly 4 texture rows. If I move it forward, okay, it's now including 2 texture rows, but its height is doubling. Okay, so as the height doubles, the number of texture rows is halved, and again you've got this invariance law where n is the number of rows, s is the height of the cup, or s times n equal k. It's always a constant. Okay, and so this would be an example of invariance law where there's this invariant ratio of size to number of texture rows included as I move the cup back and forth across this gradient, which is helping specify the world as stable when I move my cup back and forth. Okay, as the size of the cup does not change, even though the size is growing on the wet retina as I move the cup back and forth toward me. This ratio is constant, and so I don't perceive the cup as changing size. There I have forgot to say, 2 texture rows included, but the height is doubling. Here's another one. It's an optical flow field. So we're putting this whole gradient in motion. Now it's a gradient of velocity vectors, where, again, the value of each vector is proportional to 1 over the distance squared, again, the distance from the observer. So the fastest moving vectors are closest to you if I'm standing far away at the border, where it says optical flow field, and the slowest moving vectors are furthest away, near the mountains. Okay, there's a good example as I'm driving along, velocity flow fields. There's all kinds of interesting little things defined over these flow fields, like the tau ratio, which I've got specified there. Don't ask me to translate what it means. And you can see it involves the velocity over time. And but this ratio has been shown to be useful for things like coming in for landing, because it specifies the severity of impact. If the tau value is too great, that is, I'm coming up too fast, and if that flow field is too fast, I'm going to crash. You know, as a bird coming into land, I'm using this tau value to modulate my wings so that I land nice and softly. Or as a pilot, I land nice and softly on the runway. Okay, so here we're starting to get a picture of the information is getting, not information in the light and that dynamically transforming optical field that the brain is modulating. The brain is getting into the action systems. Those ratios are being used to specify virtual action, how I can act on the world. Okay, so here's an example of I gotta move your picture. There's also what's called grasping tau. That is, as I'm moving the cup back and forth, for modulating how I grasp the cup. Okay, again, this information getting in, optical information is getting into the action systems to modulate, specify how I can act, or affordances. Now, if we get more dynamic, I like to do what I call the Gibsonian cube, because if you were a rotating cube, you'd have a partitioned set of these flow fields, where the top would be a radial flow field, and as the side, that right side, moves toward you. Sorry, my little cube is rotating in the opposite direction up there in the corner. But if the side is rotating toward you, it's an expanding flow field. When directly presented to you, it's just a non-expanding or contracting flow field. As it rotates away from you, it's a contracting flow field. The edges and the static features of the cube are really simply sharp discontinuities at the junctures of these flows. And if you think they're not, well, here's an interesting little experiment or demonstration that Shah discussed, where I've got a rotating cube. It's wire edged, and if it's got a symmetry period of 4, so carries itself into a symmetry period. It carries itself onto itself every 90 degrees. The cube maps right back onto itself every 90-degree turn. It looks like the same thing again, right? So it's got a symmetry period of 4. It'll do that 4 times. And if I strobe the cube at an interval multiple of that symmetry period, 4, 8, 12 times per revolution, I'll get a rigid cube rotating. So I've got a strobe there. So it'll still look like a rigid cube. But, and here's my little picture here. So I've got a symmetry period of, 4, sort of saying the same thing. In phase, 4, 8, 12. Out of phase, this would be out of phase strobe, 5, 9, 13. It's no longer integral multiple. Well, if I do the non-integral multiple out of phase strobe, it becomes a wobbly, non-rigid, plastically deforming, not a cube. Okay. Now one could argue this is a constraint being violated, that normally spatial symmetry, that our nice cube that carries itself into itself 4 times per revolution, is no longer being specified. You expect spatial symmetry should equal temporal symmetry, but it's not when you have that out of phase cube. I didn't put another picture here of a rotating ellipse, that if, again, you can decompose the edge of the ellipse into a whole pile of velocity vectors going around the ellipse. And if the ellipse rotates too quickly, it becomes a non-rigid, wobbly object again. Okay, so the point being that these forms in the image, the coffee cup, the table, are very dynamic. They're dynamic forms. They're actually qualia themselves. That's why I said that the whole image is the problem. I think I mentioned where Chalmers kind of misled us, that the whole image is qualia. We're trying to explain the image of the external world. It's all qualia. Hence why we need the brain as a reconstructive wave specifying a portion of the holographic field. As we'll see, that holographic field is qualitative of itself. We're specifying the cube, the coffee cup, is a qualitative portion of a qualitative field. So all of these are examples now, I think, of invariance laws. I think the velocity vectors in the distance, the height of the cup, rows occluded, the Tau ratio. It's all information that is specifying or useful for part of the specification of the environment, the external world. It's not Shannon's definition of information, nor can it be brought under Shannon's umbrella. This is Gibson's information, and it's resolutely and adamantly ignored in the neural net and computer model mind. As you can see, it can't be.
Why can't it be?
Well, it's obviously important. That was my simple. It's too important to ignore. So, putting it all together. Back to my coffee. It's got all these invariance laws defined over that coffee cup. The radial flow field, an adiabatic invariant. There's a ratio of energy of oscillation, the frequency of oscillation. I move that spoon. An inertial tensor, finding the various momenta of the spoon. These are all defined over time. You don't find the value of the energy of oscillation, the frequency oscillation, as a static point. We'll come back to that. Acoustical invariance. You got the spoon clinking against the cup as the spoon moves, and sound. You've got ratios relative to the texture gradients and flows. I can move that cup back and forth on the texture gradient. Remember, constancy remains the same. If I had a cubical cup, I could be rotating my cup, and now I have that Gibsonian cube with all the flow fields defining quote, edges and vertices of the cup, etc. Grasping tau, as we noted, for grasping the cup, etc. So back to my picture, our little coffee cup, our innocent little coffee cup is this invariant structure. And the invariant structure that's what I say is driving the modulation of the brain as a reconstructive wave. But I think now back to your question of, well, can we really talk about, quote, frequency 1 or frequency 2? Really, only in the metaphoric sense that it helps us understand the holographic reconstructive process. Because this is obviously very complex wave form, right? At this point, if you visualize the brain dynamically changing over time, being driven by this structure, it's obviously a very complex structure that's being enfolded into the brain. And yet, ultimately, the vision is that it's all comprising this reconstructive wave. And as I noted before, all models of the brain have to address this dynamic structure. Because it's obviously the information that's specifying, it's obviously the information that's defining the event, defining coffee stirring. But neural nets do not and cannot, partly because they're in this completely different model, they're in a different model of time. The neural net is simply a instantiation of a Turing machine, and the Turing machine is a discrete state model of time. We're moving state to state 0 to state 1, et cetera, We're moving from state to state as we move that tape. So you've got an intrinsically different model of time in the computer model as opposed to what we're going to need to support this holographic field reconstructive wave invariant structure model. And we're going to get to that.
Would it be fair to break it out in terms of the computer model being a discrete view of time?
Yes, we're about to launch right into that because that's another
continuous
piece.
Okay.
Yeah, I had one more thing to say about invariance laws. It's kind of interesting. Over here, another invariance law. Here we have the aging of the facial profile, and the law specifying that aging is such. If we take a cardioid, which is like heart-shaped figure there, and place it over a skull, and place the skull on a nice coordinate system or matrix there, then if we apply what's called a strain transformation, which expands that coordinate grid in all directions simultaneously, like stretching a rubber sheet, what you do is start generating an aging of that profile. I have a picture there. You can, if you start with a child, as you do the strain transformation, you'll get the second picture there, and then the third. There's a whole series, obviously. I just picked out 3. And you can see that we're getting an aging of that profile. So interesting, because this aging is normally a very slow event, right? It takes us. We recognize that Joe aged after when we meet him 30 years later, or watch him as he grows. Mm-hmm. But the interesting thing is that the same law is going to hold in different space-time partitions, a la relativity. For example, see the burden, the essence of relativity, the real point of it in Einstein's relativity was that the same law holds in either space-time partition. In a stationary system on the bottom right there, the law is d equal vt. In the moving system, it's d prime equal vt prime. It's the same form of law. It's just I've changed the distance units and the time units in that moving system, or what I call the moving system. So the same law holds in each partition, d equal vt or d prime equal to vt prime. Invariance laws are critical in special relativity. That's probably the most important piece of special relativity, is the importance of invariance laws. Okay. And I got to see what I say here. Now, if I go back, notice I said you could raise the energy state of the body, increase the chemical velocity. So I could take that buzzing fly, and if I raise the chemical velocities, I drop in, frankly, LSD at the right proportion. I got a whole paper on that. You're going to increase the chemical velocities, but you're going to slow down the specification of the event. That fly is going to go to from 200 wing beats per second to looking like it's barely flapping its wing. Okay, and I got to keep moving you around. The slow moving wing of that heron-like fly, or maybe it's a seagull, but we won't argue here. What does that mean? Well, it means it's got a relationship to action, to the possibility of action. I can reach out slowly and grab the wing. I mean, more startlingly, let's say I raise the energy state enough so that the fly was stock still. I mean, the wings stopped. I mean, now clearly I could reach out slowly and grab it. But this is the exemplar of perception being virtual action. We're seeing the possibility of action, of how we can act. And this must be so for perception to be ecologically valid in all partitions. Because I can change the velocity of processes just by changing the temperature. I can get a fever and I can slow down time. Nature has to have allowed for this. That is, you have to have invariance laws specifying these events. And that is, the information has to be invariance laws that's invariant to the space-time partition or the energy state of the body, and that energy state is a range of energy states, and the time scale that can be specified is a massive range of time scales. Again, this is affordances. It's just an aspect of affordances that the Gibsonians never seen. Well, you can see it's too much of a stretch for them. And you're going to see why ultimately. But obviously, if the fly is affording a certain action, so is the gull affording a certain action, but it's at a different scale of time. Change the scale of time, I'm going to change the form of affordance. So, as I noted, back to where we started, aging is a rapid event. If I take it as a rapid event, let's say that that little Joe there is growing right in front of my eyes. So the same law, is employed to guide the modulation of the hand if I wanted to grasp the transforming head, the strain on the cardioid. That's the information that would be getting into the action systems to guide my grabbing that head as it transforms at a very rapid rate. Just a little aspect of nature, just criticality of invariance laws. So I noted Gibson was for direct perception. To him, the environment is directly specified via all this information. The brain is resonating to this time-extended information. Another way to put it here in my little box, the brain is resonating to the invariance in the external event. And it's directly specifying the image out there. There's no image in the brain. That's Gibson. No one can understand it. Purvis and Lotto, a great perception theorist recently, there's a little book, said, well, Gibson is now perceived as mystical. Stephen Lehar, who's another perception theorist, goes through Gibson's. I've looked at Gibson. I have no clue how direct perception can possibly be true, because for all these people, somehow the image is in the brain or in that perceptual space, that cloud I had up there. Mm-hmm. Again, to make sense, Gibson's direct perception must be placed within Bergson's holographic brain as a reconstructive wave framework. And as we're going to see, it goes notion of time. And into this, because notion of time. Another aspect of what, implicit aspect, we're specifying the past. Okay? The specification is to the past, to a past extent of the transformation of the holographic field. So the wing beats of that fly, by the time they get into the brain, they're processed, are long gone. It's 200 wing beats per second. They're long gone. So how we're seeing the past? How is this past specification possible? Well, what's the barrier to that? The barrier is this conception of space and time that we have. I call it the classic metaphysics of space and time. And we're going to compare that to ultimately the temporal metaphysic of Bergson, which allows the specification of the past. So the classic metaphysic, in essence, is an abstract space. It's a three-dimensional continuum of points, positions. I'm showing a two-dimensional continuum of points and positions there, my little points and positions. But ultimately, it's a three-dimensional. We're moving the cup through a three-dimensional continuum of points and positions. Because it's a space, it's infinitely divisible. In fact, as Bergson calls it, it's a principle of infinite divisibility. He called it, in essence, a mental diagram, the meshes of which we can contract at will, that we place beneath the extensity, the true concrete extensity of the concrete world. We'll talk about extensity a little bit later. But just imagine it's the concrete world, and we place this abstract mental diagram of meshes that we can make smaller and smaller. So when we look at motion in this framework, it's taken, as I move that cup from near to far across the continuum, it's taken as a series of, that motion is taken as a series of points on a line, which again is a space. And that line, being a space, is infinitely divisible. I can divide it into little point after point after point. But between each pair of points, I can imagine there's another line of points. Again, infinitely divisible. And so what we end up with is, this is an infinite regress. I can keep dividing between each pair of points. I can do another line. It's an absurdity because motion is now being reduced to a series of immobilities. How do you get motion out of a series of immobile points? And I should add, it's precisely the source of Zeno's paradoxes, where I'm taking that line and I'm having it successively into smaller and smaller halves, but Achilles never reaches the tortoise because it's infinitely divisible. I can never quit the process of infinite division. I can do it with a mathematical convention, but that's a magical mathematical convention, like taking a limit. But that's a mythology that mathematical convention has actually solved the problem. Whitehead tried that solution, but it's just a mythology, because infinity is infinity. The mathematical convention is simply conveniently stopping the infinite division. Now, time is interesting because now it's simply the fourth dimension of this abstract space. So we really have a four-dimensional abstract space. It's this series of instants. So each point along that moving cup is taken as an instant, shall we say. So each instant corresponds to a position of the moving cup. And then each instant can be taken as across the whole of the universe, as though the whole of the universe at that point, at instant in time, is a cube of space. For each cube, the time extent of each cube is a mathematical point, equivalent to the mathematical point on the line. But as such, each of those blocks is frozen, is static. You can't move from one block to another. I jumped ahead of myself here. But each block then is completely homogeneous. There's zero qualities, especially of motion, because you can't get in a block or a series of such blocks, because each block disappears as the next one arrives. So all you ever have is one block, then the next, and the next, and the next. Mm-hmm. So you're not going to get quality of motion like Valerie Hardcastle's list in the context of a symphony, the patrons shifting in their seats, the musicians concentrating, the curtains ever so gently waving. Those are qualities of motion, which are never talked about, by the way, the problem of qualia, but these qualities of motion. So, Descartes, looking at this, in order to reintroduce motion in this metaphysic, actually thought that you had to have, this is where you needed God, because God would have to create each block then the next block, then the next block, and the next block. That's the only way you could get the universe to evolve. So once you've frozen it as a static block, you're not going to get the next block. Mm-hmm. Again, this is precisely the metaphysic underlying the Turing machine and all of computation. It's why inherently, intrinsically, the computer metaphor is not going to be able to deal with what we need for Bergson's framework, shall we say, and mind. So let's go to that. The temporal metaphysic for Bergson. For Bergson, that transformation of the universal field or motion itself is indivisible. It is not a series of discrete states. Rather, each instant penetrates, permeates the next, like the notes of a melody. Each note penetrates, permeates the next. It's a melodic transformation, an organic continuity. Also, the matter field in this is characterized by extensity, as I noted. So there's a nice lake there. That's the concrete material field. The abstract space placed over it at the continuum of points and positions is not the same thing. It's the ideal limit of this extensity, but it is never reached. It cannot be reached. It's simply an ideal mathematical limit. This is why you can't exalt the abstract space into a reality and make it your starting point for building a model of mind, as does AI. The brain simply does not dwell in the world of the classic metaphysic. It deals in the world, that classic metaphysic, that abstract space it's created or derived by the brain in its development, its cognitive development. As Piaget spends a great deal of time explaining, all the way from age 0 to age 7, it takes to truly construct that abstract space.
Mm-hmm. Can I start one point, Steve? The top 2 points here. Would you say it's, and I'm sure people disagree, but current consensus in, say, modern physics is that space and time is discrete?
Yes.
So they would break it down in terms of like the Planck, I'm thinking, and of course we don't experience it this way because it's so minuscule, but you have like the Planck length, Planck time. Mm-hmm. That's as if you had to discretize space and time, you could possibly do it that way. But this model is different. Is that accurate?
Yes. The problem is all of mathematics is based in the classic metaphysics. And even the wave equation is based in this classic metaphysic and ultimately involves this process of taking limits such that I can arbitrarily stop in infinity. Okay, at the basis of the wave equation is Euler's identity. Or Euler's identity is Euler's description of the wave. But in order to make that identity work, eventually you take a limit to stop the basically in Euler's identity, you've got sort of a rotating cosine wave. Mm-hmm. But it always comes back to zero. In order to make it come back to zero, that's Euler's identity, e to the I pi equals 0, you have to take a limit of that relation e to the I pi, an arbitrary mathematical limit. But that sits at the heart of the wave equation. And you're exalting that abstraction into the reality from which you're trying to start all theory. See, everything's inverted in our current theoretical world. That's the problem. So, yeah, I did speaking of quantum, I did a a YouTube on Schrödinger. I think it's number 60 on quantum jumps. I mean, Schrödinger did a paper in 1952 where he utterly destroyed the whole notion of quantum jumps. He destroyed it, logically, he destroyed it. People don't realize this. So, anyhow, but again, that comes back to the fundamental nature of the mathematics underneath it. Okay. So let's see. As I said, this is important. The brain dwells or is embedded in this dynamically transforming, indivisibly transforming holographic field, or the world of the temporal metaphysic. It derives the spatial metaphysic, the classic metaphysics, the abstract space. And this is just completely foundational if you're going to follow Bergson. Okay, so specifying the past to bring it back. The indivisible transformation of the field, where there are no instants falling into the past. Again, you don't have this model of instant after instant falling into the past, which is the symbol of non-existence. Rather, you've got this indivisible flow, each instant permeating the next, an organic continuity. Well, that in effect forms a primary memory. Stealing the term from William James. The field is already, in essence, got its own memory. It's not falling into the past, into non-existence. So then, when you're specifying the holographic field, the specification is to a past extent of this holographic field. Now, this is interesting aspects of things that I haven't totally worked out, because you're going to have the resonance field of that is represented by that brain, those waves there, as only lasting for a certain period of time relative to the extent of the past of the field of the buzzing fly. Again, as in, or the wing beats are long gone. So this allows a past extent of the transformation to be specified. You don't need short-term storage areas in the brain, which is a concept filled with logical problems. Because right now, if you think about it, when I said for Bergson, the essence of the problem of consciousness was his memory stored in the brain. Well, when your perception is already the problem, you're looking at that spoon stirring and the fly buzzing. Well, are you storing each instant of that in the brain, slice by slice, snapshot by snapshot by snapshot, then trying to reconstruct the motion? How are you doing that? Where do you, who reconstructs the motion? Some internal scanner? Well, we'll talk about that in a second, but you can see that the very fundamentals of perception itself, of seeing that coffee cup, already involves the problem is is memory actually being stored in the brain? Is experience being stored in the brain? And well, the answer is no, it can't be. And something else I was going to say there, but I lost it. So, but if we'll go back to Gibson for a second, you'll see what he's saying the same thing. Notice this back to the classic metaphysics. He says the idea that space is perceived and time is remembered looks at the back of our thinking. But these abstractions, space and time, the classic metaphysics, borrowed from physics, are not appropriate to psychology. And this is adjacent order and successive order are better abstractions, and these are not found separate. I can spell R there. He says physical events conform to the relation before and after, not to the contrast of past and future. Well, again, you got to visualize that line of points, where one point is the present, points before that are all past, which have fallen away, and the points coming later are future. That's what he's saying is that's the classic metaphysic. When you take the classic metaphysic down to its logical conclusion, and the brain itself only exists for one of those infinitely small points, a point of mathematical extent in time. So that's just not applicable. Unfortunately, the Gibsonians are not paying attention to that quote. I mean, even my brilliant advisor, Bob Shaw, did papers trying to model the whole of Gibsonian ecological theory on the wave equation with its inherent problem. So, just an aside. Here's another thing that Gibson notes the traveling moment of present time, that infinitely tiny point that's called the present between the past and the future. You know, the spacious present, that mathematical point that would be the spacious present. Again, Gibson knows, well, no one can say where perception leaves off and memory begins. In fact, I failed to put the quote there, but when we're looking at the past, specification of the past, it's really, in essence, what Bergson said is the case. Perception is already a memory. Okay, all perception is memory already. So no one can say where perception leaves off, memory begins. The difficult is an old one. And notice he says in the blue there, animals and men perceive motions, events, episodes, and whole sequences. As they don't see point after point, instant after instant on a line, per the classic metaphysic. And he says the doctrine of sensation-based perception requires the assumption that the succession of items can be grasped only if earlier ones are held over so as to be combined with later ones in a single composite. He says this can be pushed into absurdity. Well, notice I've got up there Barcelow's theory of how you would store a biting transformation. I'd store it there. I'm biting a carrot. There's 3 schematic states. You know, mouth closed, mouth open, mouth closed back on the carrot. And so we store that in the brain. It's 3 schematic states. Equivalent to putting 3 snapshots on photographs on a table. Okay, the question is, well, how do I restore the motion? How do I reconstruct the motion? By some sort of internal scanner? Okay, but then I've got an infinite regress. I've now got to explain how the internal scanner, registers the motion. See, I'm doing there exactly in that picture what Gibson's saying. A succession of items can be grasped only if the earlier ones are held over, like on the table, successively, one after the other, to combine with later ones into a single composite. It can be pushed into absurdity. Yes, it can. Biting is actually a facial flow field. There's Homer there biting, or look at the facial flow fields on these biting. Or here we go. Here's an actual, biting a carrot. Okay, it's hard to store. Oh, I screwed up.
That's okay.
Back. We got to go back. Sorry about that. It's hard to store as the coffee stirrer into the rotating cube. See, again, notice. Do you see anyone in memory theory? I'm just rhetorical question as far as you're concerned. Addressing how you would store that coffee stirrer with all those invariance laws that define it, which are defined only over time. The invariant radial flow field, the inertial tensors. How do you store that? And as a series of 3-dimensional snapshots in the brain. Good luck. And then how do you restore it reconstruct it as motion? Hence, again, Gibson is relying on Bergson. Which brings us to the last thing I got here. That good old original question, the problem of subject and object. What is going on there? Because we need to remove the viewer. Somebody looking. See, remember, our hologram plate is the brain. And we have to review who's looking at that image out there. Or equivalently, we need to remove the homunculus looking at the image, whether it's in the perceptual space or or out there or somehow. So we're back to our Koan. Questions related to subject and object. The distinction of union was you put in terms of time rather than space. My original Koan. So here's the deal. Defined over the dynamically transforming holographic field, we've got an elementary awareness at the null scale of time. When I say null scale, I mean the most infinitely small scale of time you can imagine. Now, things are still always changing, but think of that change in the tiniest interval you can imagine. again, each point or event in that field reflects the state of all other points. Okay, so in essence, you've got an elementary awareness there. That at every point, every point's sort of elementarily aware, an elementary form, like truly elementary, of all the other points, taken at this infinitely small scale of time. And you've got an elementary memory because of the indivisible transformation, where there are no instants falling into the past, that primary memory. So, as I've noted, if you take our fly and take it at that null scale, that very tiny scale of time, it's almost a cloud of electrons, it's not going to have the distinct outlines from the rest of the field, the rest of the holographic field, to include any distinct outlines from our body. Our body is going to be the same thing. In other words, the objects that we think are nice and separate, like the cup and the spoon and the body, don't actually have the distinct outlines. They're all meshed into the field ultimately. It's a big spatial unity. So if I start lowering the energy state of that brain there, I'm going lowering now because I'm going to go from this very small scale to a bigger scale. I'll get my heron-like fly. Okay, and if I lower it still more, I'll get our normal scale, a buzzing-like fly. So we're starting to have subject differentiating from object, and not in terms of space, but of time. The unity of the two, the body and the fly there, is not broken. Spatial unity. Remember, there's no distinct outlines or borders between these objects. But as I impose the scale of time, I start getting this nice separate object, the buzzing fly in the coffee cup, from my body. And, in terms of time. And then I think we have to add a bit more with Piaget, the Piagetian development, where ultimately he describes this whole evolution of the child's conception of object, where he starts to realize that he's a separate object from the coffee cup and the fly.
Can I tell you a quick anecdote that this reminds me of? Do you mind?
Say what?
I just have a quick anecdote on that. You just mentioned child, and this is reminding me. I have a niece and two nephews, and this is just recalling something my nephew said to me years ago when he was a little younger. I think he was 5 or 6 years old, and we were just playing, hanging out, and he said something to me that we were separated. He was standing, I was standing separate from him, and he goes, "I'm touching you right now." And I was like, "What do you mean?" He's like, "Well, I'm standing on the floor, and the floor is touching you. You're touching the floor." And I was like, "Huh?" And he said, "Yeah, and even I'm touching the house across the street. I'm touching that." And his conception, I think it has something to do with, I think about this a lot with kids, what are they perceiving? What are they seeing? What is their the difference in terms of, and obviously as they grow up, they reach some critical period where they come into agreement with society, the people around them, as to the nature of things and what's actually happening, right? Or as we perceive it.
Yeah, they start to need a Koan. Yeah.
Yeah, but the interesting thing is, if you look at it in terms of a slice of time, let's say, and I hope it follows with what you're saying. If you were able to just take a slice of time, one Planck time, let's say, just one snapshot, everything would be the same object. Is that accurate?
Yeah. If you once you because it's one big field and yeah, they're almost I'd say yes. I'd go for that.
Something like that. Obviously, language is tough because we're trying to put to words these very complex things, and it might not even be even possible in our vocabulary to get there, but we can kind of analogize and get around it, sort of.
True.
Okay.
I think I had maybe one more thing. So this is where it's kind of interesting, because really the essence is there's no one seeing. This is This is where it gets Zen. 'Cause the specification is to a time-scaled form of the elementary awareness that we're talking about, elementary memory, defined over the transforming holographic field. And so, I mean, this is the kind of the essence of the Zen Satori, where all of a sudden you concentrate on your koan. Who is it that sees? All right. And all of a sudden there's this Satori or Kensho where you are the field. You know, there's a famous book by Douglas E. Harding, having no head, where all of a sudden you realize there's just this. There's no there's no you're that you're no there's no real separate being. You're his context he put it in. He became the Himalayas, you know, at the time. But sure. This is the essence of the of a Zen Satori. I spent some time in a YouTube discussing. I know you said you watched the Zen experience.
Yeah. And I think those are my favorite.
So right. Yeah. This is why Bergson is so Zen.
Sure.
I'm not sure what I got left here now. Well, I said that. So, well,
I have a lot of questions, even when we complete the slide share. But
so, notice this is Bergson's unique panpsychism over on the left there. It's a panpsychic model because that field is conscious in essence. It's got elementary awareness and an elementary memory, but it's not the consciousness of stirring spoons, or that experience of the coffee cup and the stirring spoon, or if you're a frog, the fly buzzing by, or anything like that. It's not yet the consciousness of frogs or humans or ants or anything, but it's panpsychic, but there is no aggregation problem. We're not trying, this is Chalmers' famous problem, we're not trying to aggregate or combine the consciousness of all the little tiny particles into the field and explain how we end up with the experience of coffee stirring. You know, how do you get coffee stirring out of a bunch of little conscious particles? Well, or to make it even worse for Chalmers, how would you explain how you now get the time scale of the buzzing fly as opposed to the heron-like fly, as opposed to the electron cloud fly out of your conscious particles too, right? Of course, time scale is never a problem for any qualia consciousness theorists I've ever seen in my life yet. So they just don't comprehend that one. But so the deal is the reconstructive wave specification dynamics takes care of this. I'm specifying this field as a coffee cup and a buzzing fly. In other words, I now have a dynamics. I have a mechanism to explain the conscious experience of the external world in this panpsychic field that panpsychism in and of itself does not have. It has no such thing. It fails miserably and drops dead on that. So that's my panpsychic field. The only other thing I had that was, I think is worth mentioning is this, that in this model, experience is not occurring solely within the brain. Therefore, it cannot be stored solely in the brain. Yes, the brain also as a reconstructive wave can resonate in the same invariance law pattern as the coffee cup we saw, as the coffee stirring. And we can reconstruct or reintegrate, in the old terminology, that experience. So if you wreck the brain as a modulating device, it's going to look like the memory is gone. A memory stored in the brain is destroyed, but all you've done is wreck the brain's ability to assume the complex modulation pattern that is involved in perception of that coffee cup, as we've been discussing. Now, obviously, then, you know, in other words, what we really are, and if you took Bergson's theory with the temporal metaphysics, is we're four-dimensional beings, and we're a long, elongated being of four dimensions, in which all of that experience, all the coffee stirrings you've ever seen, are stored in detail, not in an image form necessarily, but it's all there, and I can reconstruct it by reassuming the right modulation or resonance pattern. And so obviously you've got a whole different theory of memory implied. I've done a lot of talking about, but also a whole different theory of cognition, because we're using our experience of coffee cups, our experience of cubes, of rotating cubes, etc., to do cognition, to think. And this is where Penrose went when he was talking about why computers can't deal with consciousness. And he started up, obviously, with Gödel's proof as being an indication or the problem basically showing this. But he, along the way, in Shadows of the Mind, he started talking about what he saw as non-computational thought. And here's a little example I've got here, is non-computational. This would be a proof, a visual proof that he tried out of a computation that does not stop. It's called the halting problem. How can I show that a computation does not stop? It goes on infinitely and always ends up with the next logical result. Well, in this case, what he's doing is showing that a hexagonal number and added to a previous hexagonal number always makes a cubical number, and it never stops. And so what he does, as an example there, you've got the number 19, which is a hexagonal number, and he folds that into a three-sided cube, and then he stacks that three-sided cube over the previous cube, which was an 8, 2 by 2 by 2, a 2 by 2 by 2 cube. And now he's got a 3 by 3 by 3 cube of 27. He's going to go on and take another cubical number, which is 37, fold it in three sides, stack it over our 3 by 3 by 3 cube for a 4 by 4 by 4 cube, and that'll be 64. And obviously this can go on and on and on. So notice what he's doing. It's very visual. He's folding each hexagonal number into a three-sided cube. He's stacking the cube always over the next to make an ever larger cube. So this is a dynamic transformation. Hope I don't lose my slide. Yeah, over time. It requires a mind that's in indivisible flow, not state after state after state, where each previous state disappears as the next one comes, which is the essence of the computer model. You have to have this invisible flow or continuity, else the globality of this transformation of continuous folding and stacking cannot be perceived. And the invariance across this transformation, namely always a three-sided cube, always a cube, always ultimately a stacked cube, the variance can't be registered. So Penrose was really pointing to the essence of invariance laws as being the essence of proofs. And I need this continuous, indivisible transformation. Him being a complete mathematician and totally stuck in the classic metaphysics didn't realize what he's saying. He never has grasped the implications of his non-computational thought. And of course, he was trashed heavily in Behavioral and Brain Sciences Journal when he did a praesis of this book. They couldn't stand it, but this is what he was pointing to. This is the essence of true cognition. This is what you have to have. And this is why a computer, an AI, is never going to equal human thought. Because, again, their intrinsic model of time is the classic metaphysics, the discrete instant state of time. No matter how concrete you look at the computer itself, with all of its electrical flows and wires, etc., the essence of the machine is an abstraction. It's a logical model. You know, it can be carried out on an abacus or a register machine with beans and shoeboxes, as long as you're carrying out the abstract operations. And the abstract operations are state after state after state in discrete time. So inherently, intrinsically, it cannot do this type of thought. And you're never going to get AI. And if you notice, this is actually already simply a special case of the problem of common sense knowledge, which AI can't deal with either. It's this bête noire, common sense. Yes, there's working on LeCun is trying heavily to solve it in terms of neural net architecture, but neural nets are again simply instantiations of Turing machines. So they're faced with this problem. This is just another common sense knowledge problem. I mean, you can imagine myself. I'm going to build a mousetrap or even a lawnmower, and I got to stack a whole bunch of stuff on top of each other and make a big cube. I mean, it's so. I think that's the main thing I wanted to say. Yeah, notice I have a little note here. Penrose identified this thought as demanding consciousness, but again, in other words, he's stuck in a classic metaphysic and doesn't understand that consciousness implies an indivisible flow of time, that primary memory. Oh, and I did because this is just an example of the same thing. Piaget is just replete with this. I mean, if Penrose actually understood the literature of developmental psychology and cognitive psychology that Piaget represents, he would probably have been ashamed to do what he had said. But here's another simple example. Piaget is taking children aged 3 to 7. He's got a tunnel there. He moves those little colored beads into the tunnel, and then he rotates the tunnel. There's a half turn, and then he asks the child, well, what order will it come out now? And you can see if I do a semi-rotation, 180 degrees, the order is going to be reversed. I'm going to go in as ABC, but I'm going to come out as CBA. Mm-hmm. If I do a full rotation, I'm going to keep the order the same, right? I'm going to come out again as ABC. If I do it 3 times, three half turns, I'm going to invert the order. And, if I ask 7 times, what's the order going to be? I'm going to, well, if I know the rule by this time that the order changes, odd number of turns, the order reverses, even number of turns, the order is going to be the same as it went in, I can always tell you, 19, okay, well, it's going to be, the order is going to reverse, right? It takes the children 3 to 7 years to figure this out, this odd even rule. And in the course of it, what they do is they visualize, just like Penrose and his cubes. They visualize one half rotation, one semi-rotation. What will happen then? What if I do it again? What if I do it 3 times? Oh, okay, it's going to say this, it's going to reverse, And they'll get to a point where they can maybe visualize 4 semi-rotations, but ask, well, what will happen on number 5? They can't. They flake out. They can't visualize it. They can't keep the train of visualization going anymore. Mm-hmm. So ultimately, they come to a point where they can say, what about age 7? Oh yeah, odd number of turns, it's going to reverse. Even number, it's going to stay the same. And this all comes down to what he describes as concrete operations, which develop over 3 to 7 years. And here's this interesting quote. He says, well, operations, one might say, are nothing more than articulated intuitions rendered adaptable and completely reversible, since they are emptied of their visual content and survive as pure intention. In other words, operations come into being in their pure state when they're schematization. So notice that. In essence, the imagery, the dynamic transformation of imagery is absolutely essential in the course of development, exactly like Penrose was pointing to. It's just that as you do it enough, the images almost disappear in terms of very schematized form. And so he says, instead of demanding actual representation, each inversion will be conceived as a potential representation, like the outline for an experiment to be performed, which is not useful to follow to the letter, even in the form of performing it mentally. So this is really the essence of Piaget's concrete operations, or non-computational thought, to put it in Penrose's term, which he didn't know about Piaget. In other words, you need Bergson's device to support this kind of thought. Again, this is just a common sense knowledge problem.
Now, this specific problem, but is this an example of the kind of, call it a thought process, the kind of problem solving that a computer would find difficult to do at this point?
Yeah, common sense knowledge is, yeah, is the essence of their problem. I mean,
Mhm.
they've tried to simulate this stuff with neural nets, the developmental series, but people have looked at it and says, well, what's going on in the neural net weight, how the weights change has nothing to do with how children actually develop. Uh, but when I say common sense knowledge problem, and, my metaphor, my example I like is creating a mousetrap, out
Mhm.
of
Mhm.
arbitrary components.
Mm.
Okay, where I should have put my picture in here, But you imagine you have a little cardboard box and you have a pencil and rubber bands and paper clips and a piece of cheese and some string and some toothpicks. And I actually ran across this when I was in my teens. It was in Reader's Digest. It was a creativity test for engineers. Well, here's this pile of stuff. Can you make a mousetrap? Okay, and you can visualize making a mousetrap with imagine a box with you got the pencil drawn back. You got rubber band outside the box, and you have a little hole that the pencil goes through, and you can draw the pencil back, and maybe you put the toothpick lodged in a little groove in the pencil so that the pencil sticks there. The mouse, the pencil being toothpick being on the inside of the box, holding the pencil, and there's a string to the cheese, and the mouse pulls the string, pulls the pencil out, and, and sticks himself with the pencil. Okay, the pencil flies and hits the mouse. Okay, in other words, it's a crossbow trap. It's analogous to a crossbow. Okay, get the picture. I could make if I got a razor blade, I stick the razor blade into the pencil, and I prop the razor blade up in a corner, and prop it up with a pencil, and maybe
Sure.
rubber bands pulling it down. I'll give myself some staples to work with.
Yeah.
So there's force on the pencil, and um, the mouse has got to be a fairly strong mouse with that prep to pull the razor, pull the. Oh, it depends.
Sure.
People whip up these straps all the time.
Gotcha. So
So
if you're, yeah,
you know,
and now
maybe
and
you
this
have
is,
maybe you have the stapler fall on the mouse. I don't know, but
mhm.
this is a common. Okay, the problem is that there's no finite set of features that you could put in the database that a machine could use because the features are emerging with the transformation. The rigidity of the pencil and the sharpness and the fact that I could lodge it in the box corner. The box corner is a nice place to lodge a pencil for the axe. Uh, all these features of the pencil or the functions emerge with the transformation that the analogy transformation you're sort of visualizing. Like I could make it into a crossbow, or I could make it into a giant
Sure.
boulder trap, like
Uh-huh.
that destroys Wile E. Coyote or something like. Okay, that I've okay. Uh, so it becomes a massive problem of representation. Excuse me, of the features of objects because there's no finite list. Excuse me, all the transformations that are necessary, etc. That's the common sense knowledge problem, and you can see why I'm saying, well, just tunnel rotation or stacking cubes of one another, just part of the same uh, kind of problem,
Sure.
same thought process.
Cool. And I
And
believe
yeah,
this is your last slide, right?
yeah, I do
Cool.
believe.
So
So.
if you have
Oh,
time,
I had one.
one more.
Okay.
Yeah, please
But I
go ahead.
thought maybe that would be the one we part two if we ever do one. We'll go into relativity because that's another piece of the story of uh, excuse me, getting hoarse. Why? This is another piece of the story that was interesting because remember Bergson's argument with Einstein and relativity, and I in that time I had with Shaw, I was trying to reconcile Bergson to relativity uh, because Bergson believes in becoming, the dynamic transformation. The universe is always evolving, becoming. But you have that static block model of space time where everything's laid out in one big block because supposedly there's
Right.
no simultaneity. Therefore, there's no plane that you can take through that block that represents a universal present across the entire block, a present instance that then grow as the block grows. Okay, because I've destroyed simultaneity supposedly, and I was trying to reconcile that, and I found this article by Milik Kapik where he tries to show that the Minkowski formula for the space-time manifold or matrix, the Minkowski space-time, actually preserves becoming. And I thought that was cool, and I wrote this paper up because then it seemed like, okay, Bergson's got becoming, and this interpretation says there's at least some becoming in the static block universe. There's got to be some becoming, and that seems to be the point of reconciliation. And Shaw thought that was cool, and he gave it to Gibson, Gibson was there at the time, and Gibson read the book, read the article, and I said, well, scribbled on the top. Yeah, it's good to take big thoughts, big questions, but you should look at other things. I said, okay, well, he doesn't like that resolution, and the next day he was giving his talk at the University of Minnesota, and he comes out with a statement out of the blue, to anyone there other than someone who happened to have written that particular paper, namely me. So I'm sitting there, and I'm probably the only one that knew what he was saying, but this is the quote. He says, physicists mislead us when they say there's no simultaneity. When the camera pans to the heroine, tied to the rails, and then to the hero rushing to the rescue on his horse, these events are simultaneous. I guess we should add the train in too, speeding toward the heroine. So, and I recognized right away another one of those, oh, I know him. He's siding with Bergson. He's siding with Bergson against Bergson's argument against Einstein, because these are what's called multiple simultaneous flows that cannot be relativized. And that's another whole topic. I don't know if we want to get into that. I think it would be interesting to go into, where this absolutely destroys Einstein, and very concretely and very easily, and why relativity in its current interpretational form, that is, where the twin paradox is held to be true, has got to be ditched. And but that's another.
Okay, yeah, I think
that's another topic.
Already a lot we've covered so far. Can you? This one's your last one, right?
I hope so. Yeah, it is.
I have a number of questions. I'd love if you still have time. I'd love to just cover up on a couple things. I guess the first thing, I'm going to tackle this from different perspectives, but taking a step back and thinking about Bergson a little bit. One of the things I think is interesting is, and I'm trying to make a comparison here with, I think a lot about ancient symbols and semiotics generally, but you're familiar with the yin-yang symbol, the Taiji 2, are you familiar with that symbol? It's like two, a white half and a black half.
Oh, the white, oh yeah. Yeah.
And the paisley is in between. Well, one thing I think is very interesting about Bergson is he's spoken about as like a poetic philosopher, oftentimes. And of course, the debate we just talked at the beginning about between him and Einstein seems to be if they're two halves of the same coin. Let's say Bergson would be the intuitive, Einstein representing rationality. Would you say that's a fair kind of? It's a very broad kind of statement, but that is where they kind of.
Well, or the other way, equivalently, the classic metaphysics. Classic spatial metaphysical space and time versus the temporal metaphysic.
Sure, yeah, you can split that both ways.
Which incorporates into the latter incorporating in intuition, which is another whole topic. Which I haven't even.
Intuition was a huge part of Bergson's framework and ideology. But so I bring up the yin yang symbol because the way I perceive it's quite interesting because Bergson's usually portrayed as this poet, and that's part of the reason why he spoke, he spoke and wrote in sort of beautiful language, flowery language. It was kind of tough sometimes, I think, to sort of provide boundaries or specify exactly where he stood on certain issues, perhaps for other people that read Bergson. I bring up the yin yang symbol because it's funny, because like within Bergson, that intuitive sense, what you've brought here is a very technical framework, and it's almost like you're bringing in the rationality within Bergson's poetry. Does that make any sense? Does that congeal at all to the way you see it?
I could see it in a certain way, but but I tend to look at it as I'm just getting even more visual and more concrete than Bergson did.
No, I mean, I agree. I think you are. I think you are getting more concrete because Bergson was.
Well,
it's funny. He didn't have the language. He didn't have.
Notice the medium I'm doing. I'm doing this in a PowerPoint medium with all kinds of stuff. I mean,
sure.
I mean, one of the reasons it kind of I ended up doing those whatever number I'm at, 75 or whatever of these things is. I mean, I published a lot in academic world, but you can't express all the stuff there is and as dynamically and as neatly in articles as you can in this medium. I mean, I think this was incredibly freeing up a powerful medium. I mean, and obviously I'm sure people look at me and think I'm in a stone age on it, but because even compared to you, I'm in the Stone Age. So some of it is this medium. I guess if you looked at my academic articles, I would appear a little. I probably wouldn't be quite as. Obviously, you can only put so many pictures in an academic article, and you have to dwell more. And I tend to get a little more concrete than Bergson in those things, but there sure seems to be a whole lot of people that don't understand me as it is. So I don't. Like I said, it's very Zen. It's very. You have to have a certain intuition of soul, in my mind, to resonate to this stuff. And
I agree. I mean, and it actually speaks to perhaps a sub point of what Bergson was getting at in terms of duration with, and this is something I do we're talking both creators of content on YouTube and another place, of course, your written work. I've always found showing things in motion to have things to explain things better than static imagery. So it's funny when you're showing your GIFs or GIFs on these slides, and you show the stirring coffee cup, and you can kind of, I think, understand where Bergson was coming from, because would it be fair to say he'd argue most of science, the cutting edge physics, let's say, focuses a lot on the spatial component and doesn't give the temporal dimension its fair due or its fair emphasis. And actually, as far as the limited physics I know, it's funny, probably not all, equations are agnostic to the direction of time. It can be done backwards and forwards. That's the bare minimum I know, or I think that's the case. But of course, the temporal component is probably underappreciated or not fully.
It's just absolutely, yeah. There's so many subject matters where the temporal, the problem of time is just not grasped. I mean, like I said, when you look at the whole literature on the hard problem, you just don't see any understanding of the problem of time, period. Like just as I noted, all the examples of qualia are probably like the redness of the sunset, the taste of the qualifier. So it's all fairly static, qualities of motion, like the gently waving curtains of Valerie Hardcastle or the patient shifting slowly in her seat. So, okay, that's just not even grasped or understood. And notice that it's all, if I made this point, there's all dynamically changing qualities of form that say, hey, the whole image is form. And so your problem is, how do you see the external image, the world, the image of the world out there externally, the coffee cup and changing with this in front of this gently waving curtains? That's the problem. See, it's because of that failure of the grasp of the time and all these dynamic forms and change, that when you say, oh, I've got a model of how you see the image of the world out there, they don't even know that that's a solution to the hard problem. It doesn't even dawn on them that that's a solution. But physics, same problem. The fact that they think that they can get away with a completely discrete state model of time and capture what's actually going on in the dynamically transforming matter field is endemic to them. I know nice examples of it aren't coming to mind at this point, but
that's fine. Yeah.
But they're
how do you think this model? Sure. How do you think this model? Oh, sorry. Yeah. And also, just to be clear for the audience, I don't believe Bergson. He didn't create the term holographic theory of mind, right? You are.
No, yeah, like I said, it was
interpreting Bergson.
It wasn't until 1947. Right. So yeah,
so it was after his death.
Yeah, yes. I represent this. Let's take Bergson and upgrade him into how he probably would have talked had he knew about holography.
Yeah. Can you intuit how does this model help explain qualia?
Well, as I said, the transformation of the field is indivisible. Each instant permeates the next. It's already a qualitative transformation. So when you're specifying, the brain is specifying the gently waving curtains, it's specifying the qualitative transformation of that field at a certain scale of time. Color itself is a time phenomenon. It's a certain vibration of a electromagnetic field over time. That again, you're putting a, like Bergson noted, if you take 1 second of red light and spread it out wave by wave by wave, just that you could count in the normal amount of time people can distinguish events. You got 25,000 years it would require to count each wave of 1 second of red light for 400 billions of vibrations. But in essence, we're compressing the. Now notice when you spread it all out, it's almost back to my cubes of space. It's almost one giant big pile of cubes, homogeneous, no quality. But now when you're specifying that color, it's compressed into a 1 second of red light is now, that's what we see. We don't see 25,000 waves. We see this glob of color of pulsating red. Okay, it's this huge amount of time being compressed by our perception and by the brain processes. So it's now it's becoming more. It's now obviously more qualitative, perceptually than that huge spread out field as it would look at virtually what I call the null scale of time. But it's but again, remember that null scale of time it's an abstract limit. It never becomes the homogeneous space instant after instant of the classic metaphysics. So all quality all qualia is a function of time and motion, and at a scale, whether it's buzzing flies, heron flies, brown flies versus red flies versus white flies, versus gently waving curtains versus violent waving curtains.
Sure.
Okay.
Does this, and I'm going to jump around a lot here, but if you're thinking about the, say, the double slit experiment, does this, well, I mean, this is a theory of every sort of a theory of everything, or a theory of at least our perception of things. Does this relate to the double slit experiment in some way? And if so, how?
I'm sure it does, but I don't even know how to answer that question right now.
I know it's a very broad question, but I'm making connections here between, obviously, the double slit is, particles. Oh, sorry.
Yeah.
There seems to be a connection between at least the wave-particle duality, the observation of that, or measurement of that, and then its resultant effect on the pattern that's found on the screen, right? So this seemingly, this theory would have to at least incorporate that, or at least it doesn't have to explain it per se, but it has to be at least perhaps consistent with that observation.
Yeah, I'm drawing. It's like it's a giant disc loaded to my head, and I can't do it right now.
I understand. Yeah, this is a long conversation, so
it's a giant memory stick I have to reload.
But I think that there is probably a connection here if you were trying to make the case. Yeah.
And I don't think. I mean, I've looked a lot at the quantum theory. I've done stuff at it, videos on it. Mm-hmm. Like I noted, about Schrödinger, et cetera. But I would say that making that final link that you're actually asking for, that resolution, that's kind of a physics problem, more so than my problem. Mm-hmm. I can't do it. But yeah,
sure,
it's a good question, but.
Yeah.
Don't get the answer from me.
No, absolutely. I understand. It's something to consider for the future. The other thing I'd say, or question I have, is it's sort of coming back full circle to, sort of the top of our conversation. And some of my favorite videos of yours on your channel actually were the Zen related, Zen Buddhism, and how it relates to this theory. I think I have two, maybe more. Relating this holographic theory.
I did one on Zen number 24, and I did one on Zen and the Art of Motorcycle Maintenance.
Yes,
on that book.
I think those are some of my favorite videos of yours. So I wonder if, and this is, speculative, or let's say thinking out loud kind of territory. Do you think there's any relationship between the mind and meditation and perhaps the process of quieting those potential, say, waves, or that modulated reconstructive wave, as you put it? Is there some perhaps relationship between that and the sense of, say, oneness, say, with the world or the outside, what's outside the brain? No.
Yeah, when you go, I think I kind of get the Zen Satori experience when you go to the in the context of Bergson framework, but when you go to meditation, that's just another whole subject matter of what's actually going on there. Obviously, the Bergson framework, that says we're A, four-dimensional beings, B, we're embedded in this holographic field of which we have no actual distinction from, lays a framework for lots of things that can happen in meditation, but I just haven't really gone into that whole subject of how meditation and the brain waves and how it's operating and what's I just haven't gone into it. I don't think there's all that much understood really to go into it on it. I mean, I know you have people like, the biology of belief and these kinds of books that have been written, but no, I'm just not. I'm just not. It's just a bridge too far for me to walk over.
Yeah.
As a subject,
I'll say also, I'm jumping around a lot here, but one of the interesting videos on your channel as well deals with the holographic theory of mind and how it relates to the holographic principle more broadly. And what I was surprised by was how those two things are actually, in your opinion, not compatible.
Right.
Yeah. Can you talk about that a little bit?
I can. Probably would pictures would have been good, but
That's
you
okay.
see, Susskind. I mean, I looked at Susskind's stuff on it, and they're trying to describe the hologram as being on a two-dimensional surface, somewhere, basically digital, like bits. Okay, so volume. We can express all the information of in the universe volume-wise in terms of bits on a two-dimensional surface.
Right.
First of all, I have major problem with their bits because, as I noted to you before, bits are a massive abstraction that don't exist except over some sort of concrete embodiment. Like, to represent a bit, it takes tons of transistors on a breadboard. It takes magnetic cores and more Stone Age philosophy. Something is very concretely, doing voltage changes or whatever to represent those. And we're looking at it and say, that's a bit. Well, what is that on a surface of a black hole, for God's sakes? What is your bit other than a highly imaginary piece of information stuck mentally on your black hole? I mean, it's not a breadboard. It's not a. It's not a. It gets even worse when you look at qubits. It's even worse. Now you have LC circuits that are, with resistors and capacitors that are representing the qubit. I mean, like with Josephson junctions. I mean, come on, that's your bit, that's your qubit, it's on a black hole. What, not that there's all kinds of instantiations of qubits, but they're all worse. But that's number one. Number two, what the heck is the reconstructive wave? What is the source of the reconstructive wave that's beaming through your two-dimensional surface to project the three-dimensional world? Okay, four, and then the next problem C, how do you introduce time into this thing? Do you have a whole series of flashes of your reconstructive wave? So you have projection after projection after projection to create the coffee stirring? Oh, how is these bits, how are they suddenly becoming concrete coffee cups with liquid in them? Stirring, rotating. Come on. I mean, when you look at the conception, it's ludicrous. And so it is not Bergson's conception of a holographic field. Susskind's 2D bit hologram, sorry, but not the same thing. Not even worth looking at.
And then I would
see, you got me mad.
No, that's okay. I mean, you're passionate about it. I get it. It's something that I have to do a lot more research on and try to understand better myself. So, and one thing I'd be interested in is
the idea that they're going to use the holographic principles is somehow that's got something to do with mind and consciousness, and the holographic theory is just insane.
Gotcha. I just lost my light, so we're coming up on time. The question, like one question I would say, one of the last questions I want to ask you is, how is this theory, Bergson in general? I mean, you've been a fan of Bergson's for decades now. How is this conception? How does this influence your day-to-day life or your moment-to-moment existence, if it does at all?
Well, if I were to say spiritually, it would say, hey, I for one think that science, physics, psychology, cognitive science, given Bergson's framework, absolutely backs the spiritual vision of man, the Zen vision, if nothing more, but probably also the Hindu vision of what our actual capabilities are. I mean, when I say Hindu vision, I'm thinking of people like saints like Anandamayi Ma, you know, or Yogananda that could read anyone's thoughts or could, you know, Anandamayi Ma supposedly stopped the train engine with wheels spinning on a train platform. But that's in other words, I think that there's no conflict between science and this whole notion that's permeating people's minds right now, that neuroscience says we're just human robot forms with no spiritual component whatsoever, is utterly destroyed by Bergson, and gives us a very solid grounding in science and our own mystical experience that supports it. So I guess bottom line, from that perspective, Bergson is a great comfort. And if people want to shed the transhumanist vision of where the idea we're going to all get a nice bunch of chips because that's all we really are anyhow, and just become enhanced robots, and also there's no God, there's no karmic laws, and et cetera, et cetera. Well, get into Bergson and you can, and you'll see quickly how just shallow and superficial and ununderstanding they actually are. I don't include people like Sam Harris or Daniel Dennett, et cetera. These people are, in my mind, are extremely badly misled because they extremely do not understand the problem of consciousness and time. So that's one thing. After that, it's been a giant pain because I never thought that after 50 years that this particular conception would be so buried yet. It's buried in cognitive science that no one wants to look at. It's buried in memory theory. It's buried in perception theory. It's buried by the Gibsonians, for Christ's sake. They won't even look at it. It's buried by the Bergsonians, for that matter. Even Bergsonian philosophers can't. Well, who can't deal with it? I can just feel it. They don't want to deal with it. Oh, it's too much. Can't deal with that. So it's become a frustrating pain, and I feel like my life's mission has been a bust. So I feel right now. Let me tell you the truth. It was a good try. Maybe someone later will come along and take it up, because right now, to me, it's completely being ignored.
Yeah. Well, I'm glad it's your life's passion, or part of your life's passion, and you've picked up the torch, it seems like, from Bergson on this, and tried to keep his ideas alive. So it's
I'm no different from Bergson in that respect. I mean, he watched himself be buried. Along came Skinner in his rats.
Sure.
And after that, the computer model of mind. I mean, the complete antithesis. Yeah. The computer being the absolute embodiment of the classic metaphysic, the realization, almost the wet dream realization of how we can instantiate the classic metaphysic as, quote, mind. Mm-hmm. I mean, he watched that. He didn't see the computer thing coming, I'm sure, but I got to live through that one.
Yeah, absolutely.
And it's still there.
All right, Steve. Is there anything you want to leave us on? Tie this thing up in a bow? Where can our viewers? How can people learn more about you and your work in Bergson?
Well, yeah. I have a little website. It's stephenerobbins.com. STEPHEN.
I'll put it below. Yeah.
Yeah. Stephen E. Robbins and Stephen E. and Robbins.com. That's all. It's got all my articles on it. It's got a link to the videos. And the videos, I think, is the same channel. I think StephenERobbins.com. Or Stephen E. Robbins. I'd have to flip out and look at it, but yeah. So yeah, I have stuff there that people can look at.
Yes, you do. You have your website.
It's probably like 20 academic articles.
Yeah.
Academic journals.
They're all. So I'll link in the description below your website, your YouTube channel, and I think I might parse out a couple of my favorite videos of yours to share with my audience. Yep. So Steve, I want to say thank you so much for your time,
it's been great fun.
Energy. This has been fun. There's so much to think about and kind of let stew in my brain to try to make this all congeal. But thanks again, and this has been a wonderful time, wonderful conversation.
Oh, it was great fun, Carlos, and I do hope people get something out of it, enjoy it.
I'm sure they will.
All righty.
Thanks, Steve. See ya.
See you later.